Hello.
All right, so we did have a couple other students sign up, but let's go ahead and get started. If they pop in, great. Otherwise, we can just go from here. So before we get started, I just do want to let you know that this is live streaming to Facebook. If you'd like, I can go ahead and disable your camera, and that if you don't want your face to be shown. I'm going to turn on my camera here in a second. What do you think, Bud? Do you want me to disable your camera for you?
Sure.
Okay. All right, let's go ahead and do that. Okay, that's just to protect your privacy if you'd like, but as a librarian, I don't mind if folks see me. Okay, so let me go ahead and get my camera turned on. So howdy, my name is Eric, and I'm one of the technology librarians at Loveland Public Library. We do a lot of 3D printing at our library. In fact, we have 5 3D printers. 2 of which are the large ones that can print up to a foot in height and width, and then we have 2 smaller ones, and then one just for teens. So since your mic is still on, have you done any 3D printing, Bud?
No, I haven't 3D printed, but I have 3D modeled at school.
Okay. Have you used Tinkercad or what other software?
I do not use Tinkercad. I use, forget what it's called. It's like some sort of Sketchcad.
Okay, so probably SketchUp. Does that sound familiar?
Yes, that's it. Yeah.
Okay. So the really cool thing about Tinkercad is it's actually a lot easier than SketchUp, but there's some things that you are going to find that are going to be similar. So I did send a handout your way. If you'd like, I can resend it again after the email, but we're going to kind of go over some things together, and the handout's mostly just if you have questions down the road.
Okay.
One other really good thing about today is by participating, you automatically get entered to win the 2 technology summer reading program prizes. One of which is a giant 3D printed dragon. The other is a $50 coupon for the iCrate Lab, which you could use for 3D printing, for the carving mill, for the poster printer, for things like that. So
That's cool.
are you ready to get started?
Yep.
Okay. Awesome. I'm just going to double check, make sure we have no other students. They might pop in later, but I'm going to respect your time right now. So before we get started, I'm going to go over just a couple things with Tinkercad, and then I'm going to show you how to make an account. So first thing I'm going to do is share my screen to our PowerPoint right here. And in a little bit, I will show you how to actually create an account. Alrighty. So Tinkercad, how it works is you're going to be using a web browser, meaning you don't have to download any software. You don't have to install anything special. You can use it right online. You can use it on a tablet. Oh, wait, we've got another student. Okay. Good thing I didn't get too far in. All right. Hello, we've got another student. Are you able to hear me, Nancy?
Yes, and it's actually Wilson. It's my son.
Wilson, okay.
He's using my Zoom link because I couldn't get him in on the other computer.
Okay,
Not a horrible time with the
link. Wilson, you're okay to keep your camera off. I just like to warn folks, this is being streamed to Facebook, so you can keep your camera off for your privacy. But if you're ready, I've already got another student on, and we can kind of keep going.
Okay.
Awesome. All right. Just to recap, Wilson, my name's Eric. I'm one of the the technology librarians at the library. And feel free to talk, because since it's the 2 of you students, we can kind of talk back and forth. Have you ever done 3D modeling or used Tinkercad before?
Yes, I think at one point, but I tried to do it and I couldn't ever get it to do what I wanted to do, and even my dad works at a place where he does that kind of thing, and he designed all the little things I wanted, and I couldn't build anything barely complicated.
Oh no, okay. Well, Tinkercad is really, really easy. I've taught kiddos as young as 4 and then seniors as old as 84 how to use this software. So it's going to be a lot of fun. Now, this is the very first time that we've tried to teach this virtually, so we might run into some hangups, but what I'm going to do first is I'm going to give you an overview of the software, and then I'm going to show you how to make an account if you don't have one, and then we'll kind of get started. And so I'm going to also show you how to split your screen to where you can view what I have on my screen and then have Tinkercad in the same window. So Cole and Wilson, are you guys on computers or are you on tablets?
Computer.
I'm on computer. I'm on a computer.
Perfect. Okay, because a tablet might be a little bit tricky. So, okay, I'm going to go ahead and share my screen again, and then that way we can get started where we left off. All right. So what I was explaining is that Tinkercad, it's a free software. Anybody can use it, no money. You can use it right in your internet browser. You don't need to download anything. You can use it on a tablet and just use like the touch features on your tablet. Otherwise, you can use it on a computer. I find it is easier on a computer because you can use your mouse. But how it works is you're using pre-made shapes to make more complicated shapes when you put them together. So anything that's a shape in Tinkercad, it can be altered, resized. You can have parts cut out of it. There's a lot that you can do with just a couple dozen basic building blocks. So like I was mentioning, you can kind of see here in my slide how we have some geometric shapes on the left that are, we've got some rectangles, we've got some curves, we've got some circles. But then if you looked on the right, you can see how those geometric shapes, when you combine them together, they can actually make these real life designs. So can you guys kind of see the difference here? How some rectangles can turn into a bracket or a bolt or things like that?
Yeah, I do.
Awesome, awesome. So it looks really simple to get started, but I promise you, you can actually make a lot of fun stuff. And in a little bit here, I'm going to show you some samples of things you can make with Tinkercad. So how it actually works is 3D models, they're created with what's called polygons. So have you guys seen what a chain link fence looks like or what chicken wire looks like? Does that sound familiar?
Yeah.
Yep.
Yeah, so now you know how with chicken wire, you can mold it into any shape, right?
Yes, you can.
Yeah, so you can kind of see here on the slide that I'm showing you, what the 3D model uses is called a mesh. It's a blueprint. So the more curvature you have in your blueprint, the finer your shapes are. But the less curvature you have, the more geometric your shapes are. So underneath the head that says start, you can see that there are fewer lines. So it's more of a jagged geometric shape. But then if you go down to the bottom right where it says advanced, there's a lot more curves there because, and you can see things like the eyes and the lips. So that's more polygons, that's a finer mesh. So the reason I wanted to explain that is with Tinkercad, we're going to be using geometric shapes. So we'll be able to make things that look a little bit more like the top row where it says start, basic, simple. We won't be able to make too many things that have a lot of curves or a lot of kind of organic bulbous shapes. So if you wanted to make something that looked like, you know, a perfect human, maybe not with Tinkercad, but you can still make some things that are pretty awesome. Does that make sense?
Yeah.
Yep.
Awesome. Okay. So you both have had a little bit of experience with 3D modeling. Have you used 3D printers yourself? Cole, I'll ask you to talk first.
Well, my shop class at school has a 3D printer, but I've
Mhm.
never used it.
Okay, okay. What about you, Wilson?
I have used, I have used my dad's 3D printer. It's not very big, but I've used it.
Okay, okay. So you both kind of have a little bit of an idea how it works. A 3D printer, it moves in 3 different ways. It moves side to side, back and forth, and up and down. That's how it makes the 3-dimensional shapes. So in our diagram here, you can see how the bed where the plastic actually gets laid down, that moves back and forth. That's called our y-axis. Now, the apparatus that heats and melts the plastic, that moves side to side, and that's called our x-axis. And then the whole thing raises up and down on some rods. That's called the Z-axis. So when you guys, the library is open right now for appointments for folks to use our Makerspace Lab. So that is something you guys could do starting tomorrow if you want. If you've never used it, we do ask that you sign a waiver. And since you guys are younger, you will have to have your grown-ups sign that as well, just to make sure things are safe. But you can use the 3D printer in our iCrate lab. And so that 3D printer looks like the one I have in our image here. It's called a Lulzbot Mini version 2. Have you guys seen one of these in real life?
I've seen one behind the desk at the library.
Okay, awesome. So they're honestly very easy to use. And even though we have to do social distancing at the library right now, we can still kind of give you some hints on how to use this. And we're very happy to show you. And the other great thing is by you guys taking this class, you're going to get your first 3D print free, as long as it kind of fits within some parameters. But we'll do that for free for you at no charge. So, okay. And I'm going to go ahead and play this video real quick. Let's see if it plays. It should. It kind of shows how the 3D printer functions. All right. So that kind of gives you an idea of how it works. So the plastic that goes into the machine, it gets heated between 500 and 600 degrees Fahrenheit. It squirts out of a nozzle in very, very fine layers, thinner than your fingernail. And then each layer builds on top of the next. And then once they cool, it solidifies and you have a model. So the final thing I want to just mention with Tinkercad, what we're going to be doing because of the geometric shapes, we're going to be resizing and moving the shapes by grabbing the edges or the points where the shapes come together. So it's going to be really easy, I promise, but this is going to be a little bit of a geometry lesson for you guys. You guys have probably done a little bit of geometry in school, am I right?
Yep.
Yeah.
Well, actually, I'm homeschooled, so.
Oh, have you started with any geometry yet?
Right now, I'm doing fractions.
Okay. You will more than likely get to geometry very soon, but in the world we live in, geometry is all around us. So this is actually going to help you learn about the metric system, about different geometric shapes, things like that. So you're going to be engineers by the time you are done with this class. Miniature engineers. I'm not super great, but you know, I can make some pretty cool stuff. Okay. Alrighty. So let me close our PowerPoint. And I am going to get us to the Tinkercad website, and I'm going to show you how to make an account. But before we do that, I want to show you how to minimize your screen a little bit. So what I want us to do is we need to have our Zoom windows small and then our Tinkercad window kind of right next to it so we can see them side by side. So let me share my screen again, and I'll show you how to do that. Okay, so you can see here I've got an internet window, and then in the top right there is this little button called the maximize button. if I click on this, see how it kind of snaps it to be a little bit smaller? And then if I click on the sides, can you guys see that little white arrow that pops up? Looks like a two-sided arrow. So what I want to do is I want to drag this to be about half the size of my screen. And then on the other side, I want to have my zoom window be about half the size of my screen as well. Now it might be a little tricky. It's kind of hard for me to show you because the zoom window wants to place itself over the rest of my screen. But what we want is to where you can still see my screen, but then see Tinkercad at the same time.
One thing, I already have an account.
Oh, perfect, bud. Do you think you'll be able to log into that?
If I can find my mom's password page, yes.
Okay. If not, we can make a new account for you real quick. It won't be super hard.
I got it. I just
Oh,
got
awesome. Okay.
to type it in, so I might need a minute.
That's okay. So Cole, are you able to get to the tinkercad.com website?
Yep.
Awesome. Okay. So what you want to do is you want to click this button that says Start Tinkering, and you want to click where it says Create a Personal Account. We are not going to be doing the students join a class because that's a little bit different than what we're doing today. So you want to click the button that says Create a Personal Account. Do you have an email?
Yep.
Okay. And let me ask you real quick. Are you 13 or older?
I am 12.
Okay. So Tinkercad does this really strange thing where you have to be 13 or older to agree to the license. So what I will ask you to do is if you want to go grab your mom real quick so that she can put in her birthday and give you permission to use the website. We'll give you
No,
time.
I
to do
already
that.
have
Sound good?
signed in.
Okay.
I'm good.
Okay. So then we'll want to do sign up with email. And then here's where you have to put in the birthday. So if you have your mom's permission, you just want to put in your mom's or a birthday for an adult. So if your mom gives you permission to do this, then you would want to put in that permission. Sound good? Okay.
Okay, I'm in.
Awesome.
Just need to size my windows correctly.
Yeah, that might take a little playing around with. But you guys are troopers. This is the first time we've done a virtual Tinkercad class, so you guys are doing great.
All right. Okay. I got half the page.
Okay. Are you almost there, Cole?
Yep, I'm in.
Oh, perfect. So you already signed in and everything.
Yes.
Oh, even better. So then I'm the one who's behind. All right, so let me get myself signed in. And then once I get signed in, I will go ahead and share my screen again so that we're only seeing Tinkercad. And then if you guys need a hand with sizing your screen, just let me know, okay? Okay, so let me share just Tinkercad. Okay, perfect. So if you guys received that handout that I sent, there's a couple things I want to show you when you first get into Tinkercad to help you get started. So mine is probably going to look a little bit different than yours. I have a lot of projects on here. I have hundreds and hundreds of things I've made. Your account might look different, but once you actually start making things, they're going to show up right here in your dashboard. Now on the left-hand side, we have projects. So you can actually group your designs into individual projects if you want to. We also have the ability to make circuits and code blocks. So what that means is with Tinkercad, if you click this circuits link right here, you can actually, it teaches you how to make different circuit boards. So you guys could play around with that if you want to. I'm not going to show it to you today, but it's really cool. It shows you how to make and put together circuit boards. So that could be a project that you play around with. And if you submit that project to us at the library, we're going to enter you into the summer learning program drawing again. So the more stuff you do, the more entries you get into summer learning program. Now, code blocks is kind of similar. It basically shows you how Tinkercad is using the code to make the shapes. So that's something you can play around with too if you want to. But like I said, we're not going to go into it today. But this link right here that says lessons, this one is actually something I encourage you to play around with. What this is you can get started with the different tutorials. It's under lessons here, or if you go up here to where it says learn in the top right. After we're done today, you might still have questions. And of course, you can always reach out to me, but these tutorials will walk you through additional functions with Tinkercad. So starters will teach you the basics. Lessons will teach you how to make specific things. And then projects are going to teach you all of these different things that you can play around with. So give that a shot when you're ready. But for right now, what we want to do is I want both of you to go ahead and click this blue button that says create a new design. And let me know when you're there. Because your screen should look like mine with the blue work plane that looks like graph paper.
There.
Okay. What about you, Wilson? Oh no, it looks like we lost Wilson. Oh, drat. Well, we're gonna keep going just to make sure we make it with time. Hopefully he'll be able to get back in. If not, I'm gonna be posting this on Facebook, so anyone will be able to access it. Oh, there we go. He came back. All right.
Sorry, the computer died or something. I'm not sure.
Oh no, that's okay, bud. Well, basically we had just gotten into the dashboard and we were hoping you were coming back. So, do you need a second to get back, log back in?
Well, actually, I think I'm logged in on this computer already.
Perfect. Okay.
Just need to resize the tabs again.
Okay. Cool. Well, I'll just start talking about a few things, and then that'll give you time to get into a new design and get your tabs resized. So, what we're looking at right now is called our work plane. So, if you actually look at the work plane, it looks like graph paper. So I'm just zooming in here a little bit. It looks like graph paper. Now, what we're going to be doing is we're going to be placing shapes on this graph paper to play around with them. But there's a couple things we want to go through first. And I've got the handout open on the other computer. Like I said, you guys can refer to this handout later. So the basics that we want to look at are on the right-hand side, we have this whole menu that looks like different shapes. So if we scroll through this menu, we can see all the different basic shapes that there are to play with, which we're going to play with here in a minute. We also have this drop-down menu right here that gives us additional shapes that we can play around with. There are a lot of fun things in here that we're going to get to in a little bit, but for right now, I just want to show you where they're at. And then on the left-hand side, in the top, the top left, this is where you can actually name your design. So if you guys are able to follow along with me, if you click on the name, Tinkercad always names the design something very strange. So mine right now is named Dazzling Hobby Sango, but I can change it to be whatever I want. So if I click on it, I can actually type in here. I'm just going to type test design. When I hit enter, that renames my design. So this is a good way to name your designs, because when we actually go to download these later, this is going to be the name of the file. So feel free to rename your design right now, whatever you'd like it to be named. Okay.
Speaking of, I'm in and everything, and I have the work plane and everything.
Perfect. Awesome. So go ahead and rename your design. You can name it whatever you want. Okay. All right. So then some other things over here. We have this home button. So the home button, it basically will help us get to this nice default view of our graph paper. Like let's say we get all cattywampus. We can't find where we're at. If we hit the home button, it takes us back to a default view where we can see everything. We also have the plus sign, which allows us to zoom in. We have the minus sign, which allows us to zoom out. And then this cube up here, if we click and drag it, it allows us to change our camera angle. But I found that it's actually easier for us to change the camera angle by using the right mouse button. So on your mouse, if you right click and drag your mouse, that allows you to change your camera angle. So what that means is, let's say I put a shape on my work plane here. I can zoom in by hitting the plus sign, but if I want to be able to look at different angles of my shape, I click and my right mouse button and I drag around, and that changes how my view is. Does that make sense to you guys?
Yeah.
Yep.
Awesome. Okay. Honestly, it is very easy, but you can use this cube here to move your camera or your right mouse button, either one. Some other important things that we have over here are actually going to be in the top right, import and export. Now those I'm going to show you when we're done with our model, but that's how we can put
Upload it to an SD card and then put the SD card in the 3D printer to print it.
Yeah, basically, yeah. Or we can actually bring outside files into Tinkercad, but I'll show you that in a little bit. So what we want to start off with is actually placing some shapes. So it's really, really easy. In our right-hand menu over here, all you have to do is you click on a shape, drag it to the work plane. And then once you have that shape there, if you click and drag, you can move it wherever you want. And you can put as many shapes anywhere that you want. And then you can see here how I put 3 shapes down. I can then pan my camera and look at all of the shapes. But if I want to move a shape, I just click on it and drag it, and that moves it. But I've also found it can be easier to move a shape by using the keys on your keyboard. So if you click on a shape, the arrow keys on your keyboard, if you tap those, it will allow you to move your shapes as well. So sometimes this is helpful if you need to move it just a little bit and not a whole bunch. So you can see here how I'm going to click on the orange cylinder. I'm going to use the arrow keys on my keyboard to move my shape around. It's pretty simple. One thing I want to mention is that it's usually best practice to put your shapes in the center of your graph paper, because that way when you zoom in, you're able to see all sides of your shape when you zoom around. But let's say I put my shape way over here and I pan my camera, well, I can't see it because it's out of my camera. So I tend to put my stuff in the middle so I can see it easier. Does that make sense?
Yeah.
Okay, awesome. Okay, so what I'm going to show you now is we're going to actually learn how to manipulate some of the shapes. So I'm going to get rid of these and I'm going to place a new shape down. How about this yellow star here? Now, when you click on your shape, it comes up with these different white and black points. these are called the resize points, or if you remember from earlier in the PowerPoint, these are our vertices and our faces of the shape that we can drag around. So if I click one of the white points, see how it turns red? If I click and hold, I can drag it, and that's going to resize my shape. So the white points are going to resize length and width at the same time, but the black points are going to resize either length or width. So let's say if I grab this black point here, move my mouse this way, it's going to shrink it that way. Or if I move my mouse this way, it's going to make it longer that way. Also, the white point on the top of the face or the top of the shape, that makes it taller or smaller. So that changes the height. And you can see as I click and drag, the number next to my shape changes. So that tells me how big my shape actually is.
And I actually have a secret that I
What's that,
figured
bud?
out. Above in the bottom right-hand corner, click Edit Grid and you can change it to inches.
Yes, exactly. Great point, bud. So what I will tell you though is 3D printers, they default to the metric system. Can you guys guess why? Let me give you a hint. So the reason that 3D printers use the metric system is that the increments of movement are very, very small. It's easier to understand 1 millimeter in movement versus a very small percentage of an inch. So most of the world uses the metric system. The United States is one of only a few countries that uses what's called the empirical or the standard system. So it is really good for you guys to practice using millimeters and centimeters in Tinkercad for 3D printing, because the 3D printers only understand metric. So while yes, we can change this to be inches, there's a couple things that could happen. So like, let's say, you know, my shape here, it's 5.17 or 5.157 inches long, and then it's 1.37 inches wide. I could, when I download this shape to print it, it might stay the same size, but sometimes what happens is because the 3D printer only knows how to read metric, it's gonna read that as 1 millimeter and 5 millimeters. So our star, instead of being this size, is gonna end up being teeny tiny like that. So it's really good practice to make sure you're using millimeters. But you can change the grid if that is more comfortable to you. Just try to remember to change it back before you 3D print it. Make sense?
Yeah.
Awesome. Okay. What about you, Cole? Did you have any questions or any
Nope.
concerns?
No question.
Yeah, what's that?
I said no questions.
Oh, okay. Sorry, bud.
Sorry.
Okay. Awesome. Okay. So we've kind of learned how to resize our shapes that way. And I showed you a little bit about that grid. I do want to show you this thing called the snap grid down here at the bottom right. So what that means is whenever I resize or whenever I move with my arrows, it's moving my shape 1 millimeter because my snap grid is set to 1 millimeter. But that might not be the size that you want your shape. So if you change this, you can actually change it to be smaller increments. I tend to use 1/4 millimeter because the 3D printer defaults to 1/4 millimeter of height in resolution. So when I drag my shape, it resizes 1/4 millimeter at a time, or if I move it with my keyboard, it moves it 1/4 millimeter at a time. But you are welcome to play around with this, test it out, see what works for you, because as you're designing your things, you'll find that some things work better than others. The final thing I want to show you down here in the edit grid part is the shape of the size of the work plane. So the 3D printers at the library have different sizes. On your handout that I sent you in the email, it does list the different sizes of the 3D printer. So the large 3D printer has a capacity of 250 millimeters. Oh, why is that not editing? There we go, let's try that. 250. So you can actually change your work plane to be the size of the 3D printer. So if I were going to use the large 3D printer and my work plane was this size, I would know, okay, my shape fits just fine. You know, it's not too big. I could even make it bigger, and hey, it's still going to fit there. But let's say I was going to use the smaller 3D printer in the iCreate lab. Now that one really only has 150 millimeter size capacity. So this shape would be too big for that 3D printer. So I like to size my work plane knowing which machine I'm going to use. So that's something you guys can keep in mind for later if you want to. Okay. So there's a couple things I'm going to show you about shapes before we keep going. So I've got my star shape here. If I scroll or zoom in a little bit, can you guys see these curved arrows that pop up?
Yeah.
Okay.
Yep.
Yep, so you can see one here, you can see one here, and you can see one down here. These are the rotation compasses. So what that means is if I hover my mouse and I click, I can drag and rotate my shape. And you're able to rotate your shape in 3 different ways because we've got the 3 axes, remember, X, Y, and Z. So this rotation compass will flip my shape upside down.
And one other thing, if
Yeah.
you hold shift while doing it, it will do it in 45-degree sections.
Exactly, yeah. So when you first click on it, if you keep your mouse really close to the shape, it defaults to 22.5 degrees. If you drag your mouse a little bit further out, see how I have that red line there? Then you can rotate it 1 degree at a time. But like you said, Wilson, if you hold down shift and rotate your shape, it'll do 45 degrees at a time, which is very helpful if you're trying to just flip something over. Like I hold shift, I want to flip this 90 degrees. There you go, easy peasy. But then you can see how this rotation compass, it's going to just spin it around this way. And then this one is going to flop it upside down this way. So you can move it in 3 different directions. Just one thing to note is that Tinkercad doesn't remember how many degrees you rotated your shape. So let's say I rotated my shape 21 degrees this way, but then I go to rotate it again, it doesn't remember that it was rotated 21 degrees. So if you're trying to get something very precise, you have to just kind of remember how far you rotated it. But now is the perfect time for me to show you how to go back. So you can actually undo steps that you did. This is very helpful when you're 3D modeling because oftentimes you have to go back. The other great thing is Tinkercad remembers every single step that you do. So I could keep going back until the very first time that I opened my Tinkercad work plane here. So there's 2 ways to undo. One is on your keyboard, you could do Control-Z. You may have used this before, like in word processing programs or things like that. So hitting Control-Z, you can see on my screen it's going back and back and back to all these previous steps that I did. Alternatively, you can hit this back arrow here that's on the top left of my screen to go back. You can also go forward with the forward arrow. So if I keep clicking forward or doing Control-Y, that's going to go forward through all the steps that I just undid. Does that make sense?
Yep.
Awesome. So it is pretty cool stuff that you're able to do. But just know that once you close the browser window, Tinkercad does remember your shapes, but it doesn't remember all the steps. It only keeps track of the steps that you're doing at that time. Make sense?
Yeah.
Yep.
Perfect. Okay. So let's see. There's a couple other buttons up here I want to show you real quick before we go into how to move shapes around and add shapes together. So in the top right, we've got some different buttons that help us out. So a copy button, you can click on this button. It looks like 2 Post-it notes stacked together. What it does is it makes a copy of whatever shape you have clicked on or selected. And then next to it, we've got the paste button. Looks like a clipboard. we paste it, you can see here out it puts an exact copy of that shape. And you can paste as many times as you want and get as many copies as you want. You can also hit this duplicate button, which looks like a bunch of Post-it notes put together. What duplicate does is it makes an exact copy. It puts it right on top though. So you can see how I actually have to move the duplicate over. So that one's a little bit tricky, but it's still there for you to use. There's also the delete button, which is this trash can. So if you want to delete a shape, you click on it, hit the trash can, it deletes. You can also use backspace on your keyboard like what you would use for text.
Or delete.
Yeah, delete. Yeah, backspace or delete. Exactly. You guys are great at this. Very cool. Okay, so I'm going to get rid of those shapes. Do you guys have any questions?
No.
My only question is I really want to figure out how to be able to put shapes on top of shapes and then seal them together.
That's what we're going to go over next, bud. So you are way ahead of me. That's okay. That's the real fun with Tinkercad is you're not stuck with just these shapes. You can make any shape out of these shapes. And how you do it is by combining and taking away and things like that. I just want to show you one more thing with the shapes. So some of the shapes, when you click on them, you put them on your work plane, see how this menu pops up? It's called the shape menu. Now, all the shapes have one of these, but some of them have more options than others. So like the square or the box, for example, it has all these different options here, like radius. If I click and I drag this, you can see how it changes how round my shape is. Can you guys see that?
And eventually it would become a circle.
Exactly. And then I can also change my steps, which just means how rough that geometry is, like we talked about, the mesh. Fewer steps means more angles. More steps means it's nice and smooth. From here, you can also change like the height and the width, same as, you know, when you drag it. But some of the shapes don't have any options. Like we click this one here, the round roof, it doesn't have any options apart from solid and whole. So we're going to go over what a whole means in a little bit, but what solid means is it's a solid shape. If you click on it, you can actually change the color of the shape. You can actually make it transparent too, which allows you to see through it, which sometimes that's helpful if you want to kind of see inside of a shape. But just to note that the colors here that you can change your shapes to, that's just to help you design. It doesn't mean that's what color your shapes are going to be. Do you guys know why?
Because the 3D print filament has to be changed by you.
Exactly. So the color of your project is going to be the color of the plastic that's put into the machine. And so we typically have a lot of different colors. It varies depending on our availability. But we usually have at least 4 or 5 colors to choose from. So we'll go over that whole feature in a second. But now I want to show you about combining shapes together. So I've got 2 shapes here. I've got a purple cone and a red box. So Wilson, you asked about how you can put shapes on top of one another. Well, the first thing you have to do is you have to move your shapes up vertically. So how you do that is you click on a shape, and can you both see this black triangle that pops up on the top?
Yep.
It turns red.
Pull that up.
Yeah. So you click on that and drag it. And you can move your shape up or down. And then once you moved it up, see how it has this shadow underneath? And I rotate my camera, I can see it's hovering in the middle of the air. So now I could put this, oops, there we go. I can move this on top of my cube here to where they're sitting on top of one another. And you can see how it is sort of a delicate balance if I have to move my camera to make sure it's actually on there, to make sure it's not hovering off into space. It's like, let's say I'm zoomed in like here, I got my shape here. Well, it looks like it's on top, but then if I rotate my camera, well, actually it's not. It's hovering off the other side. So rotating your camera as you design is really going to help you make sure that your shapes are put together. I'm going to change this back to millimeters real quick. There we go. Okay. You can keep moving your shapes up and down no matter where they're located just by clicking that triangle up and down like that. And then you can see can you both see how it's not quite centered? It's a little bit off kilter here. I'm going to show you how to center your shapes at the same time of showing you how to select multiple shapes. So, we know how if I click on one shape, I can move it, but that's not really what I want to do. I want to click on both shapes. So how I can select both shapes at once is 2 ways. One, I hold down the Shift key on my keyboard and then click each shape. And now you can see how both of them are selected. I can move them both. Or this is helpful if you've got a lot of shapes. Click in some blank space and drag your mouse. Can you guys both see that red dotted line that popped up?
Yeah.
Awesome. So everything inside that red dotted line is going to be selected. So let me place another shape over here. I click off into some blank space. I drag my mouse down. There's that red dotted line. Everything inside of there is going to be selected. So now when I let go of my mouse, all three of my shapes are selected at once. You can see how they move together. I could even resize them together because they're all selected. And I know they're selected because it says shapes parentheses 3 in my shape menu. So now that we've got those selected, I want these two to selected because I want to make sure that they're centered. There's this button up here called the Align button. Can you guys see that? Kind of looks like a bar graph.
Yeah.
Okay, awesome. So I click on Align. See how these different black dots pop up? So what that's telling me is there are different points I could align my shapes to. So if I click this one here, it's going to align everything to the left. But if I click the center one, that's going to align it to the center. I could also align it to the center this way, but then that makes my cone disappear, so I don't want to do that. I just wanted that cone perfectly center in my shape there. So that Align button is really helpful for making sure your shapes are centered. And you can do that with multiple shapes. So like, let's say I've got this shape here. I want to highlight them all. I want to make sure they're all centered on the y-axis. I can click this here, and now I know it's perfectly centered. I don't have to worry about them being cattywampus. So before we continue, I do have one quick question for you though, real quick. So let's say you have a 3D model, you want to get this yellow cone printed. What would happen if you tried to send it to us for 3D printing like this, with the cone or the pyramid kind of hovering in midair? What do you guys think would happen?
It would probably just print in midair with nothing below it, so you'd have a big pile of spaghetti below it.
So you are dead on. So the 3D printer, it has to touch, your model has to actually touch the glass plate. So if you were to send this yellow shape to us to 3D print, we could print it, but what would happen is there's going to be all this material down here that's support material. So it's material that kind of holds up the bottom of our shape right here, when it's probably better for us to make sure that's just flat on the plate. So remember, we use our triangle to drag it down. Can you guys see those numbers to the right where it says 8.75, 7.75? That's telling me how many millimeters above or below the plate or the work plane that my shape is. So we want that to say 0. 0 tells me that my shape is perfectly flat on the work plane, which when I download it, it's going to be perfectly flat on the glass plate. Does that make sense?
Yeah.
What about you, Cole? Does that make sense to you?
Yep.
Perfect. Okay. So now what about if my shape is sunk down like this? What do you guys think?
Then it would probably print on the flat plane, and it would just make that little tiny piece that's sticking up.
Exactly. So what would happen, sometimes the 3D printer software will understand that, oh, it needs to bump it up like that and then print the bottom. But sometimes what will happen is it pretends everything below the graph paper here doesn't exist. So then you'd only get this top portion that printed. So just keep that in mind, that we want all of our shapes flat at 0, 0 on our work plane. It's the same thing as it's something sitting flat on the table. We want our models to sit flat on our work plane. Okay. All right, so any questions?
Nope.
Okay, so now I want to show you how to actually move or put our models together to group them. And then I'm going to show you how to remove parts of models. And then after that, we've got a few more things I can show you. And then I want to show you some samples of what you can actually make with this program. So, you know, we have all these individual shapes here. They're pretty cool, but you can't do much with just an individual shape. You have to combine them to make more complex designs. So I've got this shape here. I'm going to just add this guy, you know, why not? I'm gonna rotate it just a little bit just to make something. Now, let's say I want these three put together. So how do I do that? Well, I need to select them all. Remember, we click in some blank space, we drag down, everything's selected, everything's highlighted. In the sort of middle, almost to the right of the top, there's this button here called group. It looks like a circle and a square put together. If I click that button, it groups my shapes together, it combines them, turns them into one shape. And typically, when you group them, your shapes become one color. And you can see here how it moves and resizes like one shape. I rotate like one shape. This is now one combined shape. So I could do anything with this. It's one combined shape. If I tried to 3D print it, it would be one shape. It wouldn't be individual shapes. But let's say I need to take it back apart so I can move one of the shapes. Well, right next to group is ungroup. So if I click ungroup, see how it turns back into three individual shapes that I can then move around individually. Move that there. So now I've got my three shapes. I moved them, highlight them, I can group them again. So does that make sense, guys?
Yeah.
Yep.
Awesome. I'm going to mute you both just for a moment because there was some weird feedback going on there. I'll unmute you next time I ask a question. So, okay. Now, any questions about grouping and ungrouping before we continue?
Nope.
Nope. Okay. What about you, Wilson? Okay. All right. So now, the last thing, sort of the basic function of Tinkercad I'm going to show you is how we can make holes, how we can remove parts of shapes. So let me just show you what that looks like, and then I'll kind of explain the process real quick. So we go to the top of our shape menu. We have these shapes that are kind of shadowed out with some gray stripes. They're called holes. Now, you can see how the whole box is different than the solid box. So let's say I put the solid box down, and then I put the hole next to it. You can see here on my screen how it, oops, sometimes this doesn't want to zoom in. I think I need new batteries in my mouse. You can see here how the hole overlaps the other shape. It turns kind of a dark gray. But watch what happens when I group these two together. when I group them together, see how that chunk removes itself? Any piece of the hole that you place on a solid piece, that's going to be removed. It kind of works like a cookie cutter or an ice cream scoop. Anything that touches, any hole that overlaps another shape, it's going to remove that part. So the cool thing about that is any shape can be a hole. So let's say I have a solid box here, but then I go down, I've got this paraboloid. I place that shape. Remember, we have our shape menu that pops up here. I can turn that into a hole. I know it's a hole because it's kind of shadowed in gray right here. If I overlap the two like this, and then I group them, well, that shape cut out the other part of the shape. So anything can be a hole, even text. So let's say I've got a roof right here. Let's say I've got some text right here. Oops, my text is upside down. I turn my text into a hole. I'm gonna just type my name. Why not, right? Eric's a pretty cool name. I'm gonna make this just a little bit smaller. And I want this to be a little bit bigger like that. And then I want this to come up like that. And then I want to group or center them all like how it showed you. Now, if I group that together, now I've got a plaque that has my name embossed on it because I used the text as a whole to remove parts of my solid shape. So I'm gonna unmute you guys now. Does that make sense, guys?
Yeah.
What about you,
Yeah.
Wilson?
It makes perfect sense.
Awesome. So does that kind of answer some of those questions you had earlier?
Yes.
Yeah,
Awesome.
well, yes and no. Like, for instance, the big thing is I like coins, so I want to make a coin with a design on it.
Yeah.
So I've tried, and it's really hard, and I've only made like 2 that are anywhere close to what I want it to look like. I want to put an actual person on a coin.
Okay. Okay.
So I need heavy detail in less than an inch.
So that's a really, really cool project you have there, bud. With that said, we do have to kind of understand the limitations of the 3D printer itself. So I think now I'm actually going to take a break from Tinkercad to show you guys some other things if you'd like, so we can kind of have an understanding of the limitations of the 3D printers we have at the library. Sound good?
Okay.
Okay, and then we'll go back to finishing up with Tinkercad because I still have to show you how to download a model, how to, make sure it loads in the software. But I'm gonna stop sharing my screen so you can see my camera. So I'm gonna show you guys some other things. So let me stop my share. Okay, perfect. So I'm gonna show you some different models that I have over here. So this is a model that I printed not too long ago. It still has some support structures on there. So let me get that a little bit closer to the camera. You can kind of see here the striations in our 3D print, right? So this is about a 2.5, maybe 3-inch model. We can see the eyeball detail. We zoom in, we can kind of see the nostril detail there. So 3D printers are really good at making things like this. They're also really good at making things like this. Like this is actually a replacement part for my personal 3D printer here at home. So you can see this is geometric. It's got some different holes in it. We can kind of see the surface there. Nothing fancy. So 3D printers are great at making stuff like this, or like the dragon I showed you. But let me show you something like this. So this is actually a screw that was made on the 3D printer right behind me. So this, you can see the detail in that. And then it's kind of hard to see in the camera, but can you kind of see how it has those little dots on there, like little thumb screws?
Yeah.
So it can do that kind of detail, but that is in the horizontal like the horizontal part. If we try to do that level of detail on a flat part, we have to consider how the 3D printer functions, right? So let me show you. So something like this, we've got, let me pull that out of there. So you can see if we actually take a look at, let me see, it's a little bit tricky on this camera here, but see how the finer the detail, it gets sometimes a little bit bumpy?
Yeah.
Yeah. So, you know, when we're doing the different details this way, we have a little bit more room to play around with than if we're doing the details, you know, this way. So let me see what else I could show you. Ah, here's a good one. Okay. So you're trying to do coins, right?
Yes,
So,
I'm actually a big coin collector too.
yeah. So when we're looking at coins, we're talking about how a 3D printer is going to be printing layers this way and then doing a top part. So you can kind of see here on this what printed like this, you know, it's flat like this. And then you can see how it tried really hard to do some text, but it's just too small for this style of 3D printer, right? So remember when we talked about the 1/4 millimeter depth of a 3D printer? So the actual nozzle, it's only a 1/2 millimeter. So if you've got like a ruler, I've got one here. If we take a look at a ruler, you know, a 1/2 millimeter is just so small. You know, it's thinner, it's about the thickness of your fingernail. So a 3D printer can only do something that's 1 millimeter in length and width because that nozzle has to make 2 passes around. Remember in the video we watched how that plastic was squirting out of the nozzle. So the 3D printers we have at the library, they can't do anything smaller than 1 millimeter. So if we look at an actual coin that's real life size, you know, like a dime or a nickel, that's just too small for our style of 3D printers. However, let me look up a quick, I want to show you a sample of another style of 3D printer that can do really small things.
Okay.
We don't have this type of 3D printer at our library because they use a resin that's a little bit toxic. Okay. So
I see.
Yeah.
You don't want, yeah.
Yeah, so I'm going to share my screen again so I can show you guys. So can you guys see the picture of the pineapple on the fingertip on my screen?
My
Yes.
goodness, yeah.
Yeah. So these style of 3D printers, they're called SLA 3D printers. They use lasers and lights and mirrors inside of a bath of liquid resin, and the laser shoots through the bath and kind of solidifies the resin, and then the whole thing raises out of the bath. So it can do very small things because remember, lasers can be tiny, they can be microscopic. But with the style of 3D printers we have at the library, the plastic is a solid plastic that has to be melted and squirted out of a nozzle. So let me see, I actually have a sample of the filament here. Let me stop sharing. So right here in my hand, this is a piece of 3D filament. It is 3 millimeters in diameter. So this goes into that nozzle, melts, and then squirts out the tip at a 1/2 millimeter. So you can see how super small stuff just doesn't quite work with our machines. Does that make sense, bud?
Yes, but the one thing is I can't get it to work with the machine we have here at home. It's called an Ender 3.
Yeah, so an Ender 3, it's the same style. So it uses that plastic filament, it melts it, right?
Yeah.
Yeah, so the Ender 3, it actually, it's the same style of 3D printer that we have in the library. So they're just not quite capable of doing very small stuff. But you could do a coin that, like if you made it a little bit bigger, you could still do some pretty cool stuff.
Okay.
Yeah, it just probably couldn't be real coin sized. It'd probably have to be, you know, about yay big to where you can get some detail in it.
Which, speaking of, there actually were coins that were that big.
Yeah, yeah. So I've got another sample here. Oops. Ah. Oh, that's okay. We're good. I had all these boxes over here. Okay, so I have this sample here. It is a spout that actually screws onto a soda bottle, and then you can water your plants with. So you can kind of see the fine detail of those holes in the spout, right?
Yeah.
Okay, so it can kind of do about that detail. And so you can make a coin about this size and get some pretty good detail, but stuff that's smaller than that, it's just gonna be a little too hard. Does that make sense?
Yeah, I once tried to make a penny. I actually measured a real penny and made it the exact size.
Yeah, it can be a little bit tricky for sure.
Speaking of, it failed miserably.
Yeah, definitely. So let's see some other samples I've got for you guys. Okay, let me show you here. So I've got a few more samples here. So like this actually is a piece that prints all in one, but see how it moves?
Yeah.
So how that works is inside this this part that rotates, there's little gaps. And so the 3D printer can actually print gaps in between pieces. It just has to be, the gap has to be small enough to where the plastic doesn't adhere. So you can kind of see how it's just enough to allow this to rotate.
Okay.
And then something like this, so this is, these in here are support structures that hold up parts that need something to hold up. So like you can see here, if this didn't have something to hold it up, it would droop, right? So then it had to print this support structure to make sure to hold it up. You can kind of see that support structure down here too. So anything that's raised above that has nothing underneath it, it needs support to be able to hold it up while it prints. And then you can kind of see here how the support structure removes really easily, and then it kind of looks like this, like an accordion. Does that make sense?
Yeah. Although I do know that if you have a small enough curve that you could actually build things out, but it would have to have quite a big curve and it would have to go really slowly.
Yeah, yeah. So something like this. So this is actually a 3D printed mask that I've made a lot of for people to protect them from the virus. So, you know, you've got a curve like this. This did not need supports to hold it up. Even this part right here, it didn't need support because the curve is gentle enough that it can just build on top of itself. But if, you know, like a curve like under the dragon wing here, that's a lot. So that actually needed something to hold it up. But the chin, that's gentle enough, it didn't need anything to hold it up. So now, kind of knowing some of that, does that answer some of your questions about the capabilities?
Yeah.
Awesome. Now, what about you, Cole? Did you have any questions about the machine capabilities? Nope, looks like you're muted, bud.
Nope.
Okay.
Sorry. I didn't
That's
mean
okay. Sweet. So you guys, are you ready to go to the next step?
Yeah.
Okay. Awesome. Okay. So let's see. Our next steps are, I'm going to show you how to export your models, and then I'm going to show you how to get them set up in Cura, which is the 3D modeling software that you use at the library. So let me get rid of some of these screens, get back into.
I just thought of something.
Yeah, what's up, bud?
I use Cura when I do this, so what I can do is I can just load the same thing and I can print it here or at the library.
Exactly. Yep, sure can. Okay. So I'm going to share my screen again, and then I'll show you these last couple things. And then what we can do is I can give you guys some free design time and just hang around so you can ask questions if you have them. So, okay. So now let's say I have this little plaque that I made. Maybe I want to turn it into like a keychain just real quick so I could actually print it. So I'm going to put like a loop on it, but the loop's too tall. It's going to ruin my letters. So I'm actually going to ungroup my text, make this a little bit smaller, and then regroup the whole thing so that the hole in my text will carve into the loop as well. Okay, so this would be a very, very simple rudimentary keychain or, you know, something like that. Let's say I actually want to 3D print it. Well, a couple things I want to look at is the size. So when you click on the corner points of your model, it's going to show you the size in millimeters. So I can see here how my shape is 48 millimeters long. It is 31 millimeters wide. And then it is 10 millimeters tall. So that can definitely print. I guarantee it's going to print in 40 minutes or less. So how do I get my shape from Tinkercad to a 3D printer software? Well, we have to do what's called exporting. So with Tinkercad, you're not really downloading a file. What you're doing is you're telling Tinkercad to save your model as a file type that the 3D printer knows how to read. So you have to export it into a file type called STL. STL stands for stereolithograph. And it is the language that 3D printers know how to read. So what we do is we're going to click on our model when it's done. Remember, we have it all grouped together. It's one model. We're going to come over here where it says export. Then after it says export, we want to go to the download button, not the 3D print button. That's a false positive. That would assume that you have a 3D printer hooked up to your machine right now. That's one of these guys. So don't click 3D print. You want to click download. Then you can download it as an OBJ file. That's fine. But it is preferred an STL file because we know that's not going to have problems. So we want to click STL. And then now you can see here how it downloads at the bottom of my screen as an STL file. You have to have a program on the computer that knows how to read STL files. So most Windows computers or Macs, they do have if it's Windows 10, you have a program called 3D Viewer. You can actually open your files in 3D Viewer just to look at them. And it works pretty good. So you can see here I'm opening it. I'm actually able to see my model just fine, no big deal. However, I can't do anything with it in 3D Viewer. I need to make sure it's open in a program that talks to a 3D printer. Now, those types of programs are called slicers. The reason they're called slicers is because they break down your model into slices of layers that are then movement instructions for the machine. So the ones that the libraries use is called Cura because it's optimized for the machines that we have in the library, the low spot machines. You can use Cura for a lot of other 3D printers too, like your Ender at home, Wilson. But I'm going to go open up Cura here on my computer so I can show you a couple things about it. Because this is the exact same software that you're going to have to use in the iCreate lab at the library. And sometimes it takes a little bit to open just because it is kind of an intense program. Okay. All right. So I'm going to go ahead and mute you again, Cole, just because there's kind of some feedback there. But I'll let you unmute in a minute if you have more questions. So when we first get into Cura, we see a facsimile of the 3D printer, like a little small version. We see a glass plate, which kind of looks like the work plane in Tinkercad. We can also see that we can rotate it just like we would in Tinkercad if we want to see the different angles. Now, what we have to do is we have to load that model into Cura. So how we do that is we click the Open File button in the top left. We're going to navigate to where that file is, which Test Designed, it's in my downloads. Then it loads into my software here. So, okay, I've got my cool little keychain. I can look around it like I would any other model, like I would in Tinkercad. Now, there's a couple of things that at the library you won't have to change. So at the library, the material type, the profile, it's all gonna be set for you because we only really use one filament type at the library. That's just to make it consistent and easy. You don't have to worry about anything. So most of this stuff you're not gonna have to play around with. But what you will wanna do is you are gonna want to look at your model to make sure how long is it gonna take, how much is it gonna weigh, is it sitting flat on our plate, do we need to add any supports, things like that. So first of all, we see our model here in our solid view. But if we click solid view, go down to layer view, it actually shows us the different layers of our model. So let me change my camera here, you can kind of see. So each one of these red lines is a layer that the 3D printer is going to build our model with. We can use this slider here to scroll all the way to the bottom. We're at layer 1. We can see the red line is the outermost perimeter, the green line is the innermost perimeter, and the yellow is fill, so it's a solid layer. If we use our scroll bar to scroll up, we can see how it starts to build. Now, if you can see this grid structure in here, that's called infill. So most 3D models are not solid. This is to save time, this is to save plastic, and to also make it print faster. The more plastic it uses, the slower it prints. So by having a grid structure instead of solid plastic. Yeah, go ahead, bud. Did you have a question, bud?
So I know one thing is that you can change if it's a honeycomb pattern or I think a circle or other patterns like that.
Yes, you definitely can do that. But if you're printing at the library, I recommend you ask us first just to make sure that it's going to work out good. Sound good? Yeah, you can change it, just let us know first. So then we can see that my model here, all the layers are good. We can see that I don't need any supports. There's nothing overhanging. But let's say I rotated my model like this. I probably would not want to print it like this because it's going to hover in air, in midair. It's going to need supports that probably wouldn't need to be there. But if I tried to print this model without support, it's not going to print. It's going to fail because there's not enough touching the glass plate. The angle is too severe for it to print. So what I would need to do is I would need to click this button right here. This is generate support. After I generate support, you can see how it's going to add that accordion-like structure that's going to hold up those layers. But then it increases the print time a lot, increases the plastic a lot. So I could print my model like this. I would just have to remove all of that grid-like structure, the supports, when I was done with my model. When honestly, it would be better just to make sure it's flat. So we can go over here into our rotate button, rotate our model just like with Tinkercad. We can rotate it however we want, but then just make sure it's nice and flat. And then when it's flat, we can see this model is going to take 36 minutes to print and be 6 grams of filament. So at the library, it would be $1 because the library just charges enough to cover purchase of more plastic for other folks. So it's $1 per 10 grams of plastic. But for you guys, we're going to give you the first $2 worth of filament free or for free. So you could get something like the dragon I showed you, that would be free. That's about $2 for the filament. But if it, just show us your model ahead of time and we'll kind of look at it. And we want to make sure you get your first prints free. So you can send them directly to me or to the library technology email. Both of those emails are in the handout that I sent you guys. So now, if you've checked your model, it's flat, it fits, you're good with how long it's going to take, what you would do is you're going to hit the print button that's at the bottom right down here. I do not have the 3D printer hooked up to my computer at the moment. It's turned off. So the print button is not here. But at the library, you'll be able to click print right away because it's always connected. So, okay. I'm going to stop sharing my screen. And did you guys have any questions about that?
Yeah, I have one question.
Yeah.
So I would want to make it here and everything. Could I just bring it on an SD card, a micro SD card?
You definitely could. There's a couple ways to do it. Like I said, at the library, there's two ways to print. One is we print it for you on the 3D printer behind the service desk. Two, you can print it yourself in the iCreate lab. So Wilson, are you over 11?
I just turned 12 in April.
Perfect. So you can actually use iCreate by yourself as long as your grown-up signs the agreement. So you can, I can email it to you guys right after this. You can print it. Make sure you put library card, have your grown-up sign it, bring it in when you make an appointment. Otherwise, you can fill it out with your grown-up in person at the service desk. It's just to make sure that you understand the safety rules of the makerspace and to make sure that you're following the rules. Everyone does, though. It's just something we have to have for the library. But if you get that paper signed, you can use that 3D printer all yourself. So with that said, you can put it on an SD card, but our printers actually, you can print it via an SD card, but you would have to make sure it's set up using Cura for Lulzbot with that particular printer selected. So you could do that at home, but it's actually preferred that you just have the model, the STL file, whether it's on a flash drive, whether it's on an SD card. You'll load that model into Cura and then make sure the settings are there and then print it. If you're not sure about that, we can walk you through it beforehand, but definitely you can put it on an SD card or a flash drive, or you can just log into your Tinkercad account, download it directly to the 3D printer computer, and go from there. Does that make sense?
Yeah, it does.
Okay. Awesome. All right. So let's see. I'm pretty sure I've showed you just about everything with Tinkercad that there is. The one final thing I can show you, if you guys want, I can show you how to import outside designs into Tinkercad to play with them. What do you guys think?
That would be nice because my dad has this thing at his work that he can do even more stuff in Tinkercad.
Yeah.
So it might be possible that he makes something basic and then I upload it into Tinkercad and then can change the things I need to change.
Okay, awesome. So I'm going to show you guys how to do that. Let me go ahead and share my screen again. So you guys have heard of Thingiverse, right?
I have. I think that might be, yeah, me and my dad have looked on there multiple times.
Okay, yeah, Thingiverse is the most popular 3D model repository out there. I can actually send you guys alternatives to Thingiverse too if you'd like, but I'm just going to go to Thingiverse real quick so that I can show you how to import a model. So let's say I'm at Thingiverse. There's millions of models here for us to choose from. Let's say I want to search for, like, I don't know, like you mentioned coins. Let's just do coin. Let's see what pops up. So we have some really cool designs here. Most of these are coin organizers, but.
And many are coin banks. Me and Dad have scrolled through this page many times.
Exactly. So maybe that's not a good example, but hey, maybe I like this kind of Scrooge McDuck gold coin. Maybe I want to do something with it. So we're on Thingiverse. We click on our picture here. We can see it's been 3D printed. We could download all files. I am more partial to click where it says thing files and then just download the STL itself. That way we don't have to worry about the other files that download. Now that it's downloaded, we go back into Tinkercad. Then I want to hit the button that says import. If I click import, I can choose a file. It tells you you can have STL, OBJ, SVG. Those are just model file types that you can import. So you couldn't put a JPEG in here, like an image file. You couldn't put like a PDF in here. It has to be one of those 3 types. Also note that it has to be 25 megabytes or less. So remember in the very beginning of class, I showed you that mesh structure, the polygons. The more complex the mesh or the more number of polygons a shape has, the bigger the file size. So Tinkercad, because it's browser-based, it can't handle a lot. It can only handle up to 25 megabytes or 300,000 polygons. So very, very complex designs, not going to work in Tinkercad. But simpler stuff like this dollar coin, I guarantee it's going to work. So we're going to click choose file. We're going to go to our downloads, dollar coin. It's 0.38 megabytes, so it's small enough, perfect. Now I click import. We're going to wait a second and it's going to import here. We can see that green bar at the bottom. And voila, look at that. That shape imported in Tinkercad, no big deal. It works just like every other shape. So I could rotate it, I could resize it, I could add it to my other shape here if I wanted to. Easy peasy. So it works with just about anything. Like let's say that dragon model I showed you, the cute dragon, it's this guy here. Let's say I go to download it. This one actually has supports built in, so I want one without supports just so I can show you. Let me go back. Here we go. How about this guy? Make sure it's small enough. 1 megabyte, perfect. So we got dragon. Go back to Tinkercad, import, choose file, dragon, import. Remove my coin there. Sometimes if your internet's kind of slow or if it's a very complex model, it can take a little bit of time. So, but that went pretty quick. But now you can see how I have that really cool dragon in Tinkercad. I could do what I want with it, you know? I could add shapes. I could give it a funny tongue. I could put my name on it. Anything that I want to. I could, you know, even make it smaller. I could do whatever. So that's how you can import outside models. But because we want to be good digital citizens, I want to mention a couple things to you before you do a lot of imports from Thingiverse. So if we go back to Thingiverse, we have this thing called licensing. So whenever somebody creates digital content, whether it's a 3D model or a picture or even a video like the one I'm making right now for our class, whoever creates it has ownership of it. They have a copyright. They have the permission to use it or disseminate it or share it because it belongs to who made it. So people who make 3D models, they can say whether or not other people have the ability to download or print their models. So how you know whether a model is okay to change or to download is through this thing called the license. So everything on Thingiverse has a Creative Commons license, a different license type for different types of models. So what that means is if we look under license right here, we could see that the person who made this says that it's copyrighted to them. You can download it and use it if you want to, but you can't sell it. See how it has that money symbol with a slash through it? They don't want you to share it. You can't You can't print a bunch and sell them. You can share it with other people. It says share alike right here. And then if you're going to be printing this and doing a lot with it, they want you to attribute. What that means is you have to give credit to the original author. So like, let's say I took that cute dragon design, I altered it to give it unicorn horns and shoes, and then I put it back on Thingiverse. I would need to give it the license or the attribution that says, I got the original model from this person, I just made a change to it. So it's it's being fair, it's being ethical. So just keep that in mind. If you really want more information about this, reach out to me, or you can actually click the link underneath the license in every model type, and you can read what it means. It's just really good practice to be a good digital citizen. You know, people spend hundreds of hours making models. They put it on here for people to 3D print for fun. So it's respectable and good practice to make sure you're being fair with that person's work. So hopefully that makes sense. Just keep that in mind. You know, you wouldn't want to print 500 of these and try to sell them. You know, I wouldn't do that. You know, this is not fair to do. But if you're going to import this design, like I could change it for my personal use, but if I'm going to share it with other people, I need to make sure I tell them, hey, I got this dragon from this author on Thingiverse. So
Would I have to do that if I, like, for instance, gave it to a friend or somebody?
no, it's mostly if you're going to share it, you know, if you're going to, let's say like you edited this model, put it back on Thingiverse, you would just need to tell people where you got it from. Does that make sense?
Yeah.
Yeah, so personal use, printing it for you, printing it for a friend, no big deal. Making a change for you, making a change for a friend, no big deal. It's just when you're putting it back out into the internet, that's when you need to give credit. So, okay. So I'm going to stop sharing my screen again. Now, any more questions, you guys? What do you think?
I don't have any.
Okay, awesome. What about you, Cole?
No questions.
Okay, awesome. So we have a couple things that we could do here. I'm going to go ahead and stop the live stream because I've showed you all the stuff I want to show you. But then I could go ahead and stay on the line a little bit if you guys want to design and have questions, or if you're done, if you click leave meeting, that'll get you out of the online class. So by participating today, I've entered your names into the drawing to win the giant 3D printed dragon, and then to win the $50 iCreate gift certificate. So you guys have participated in the maker activities, and yeah, thanks so much for learning with the library and kind of being the first guinea pigs for this class online. So
Well, I'm probably going to get off and go print the thing I created while you were talking.
Awesome. So what you could do, bud, if you want, you could share a picture of that with me in the email, and I can share it online, and then that gives you another entry to win the dragon and the gift certificate. What do you think?
I'll get my mom to do that. She's the one who is in charge of all the emails and stuff.
Okay, cool. So do you know how to take a screenshot on Tinkercad?
No, I don't think so.
Okay, so let me show you how to do that. There's two ways. One is on your keyboard, there's this button that says print screen. So if you hit that button, you can actually paste that into an email. So that would take a picture of your screen, would put it in an email. The other thing is in Tinkercad, there's this button right here that says send to. If you click send to, where it says invite people, generate new link, copy link, you can share your design with me via email. And I'm going to send instructions how to do this to you guys as well. But if you do that, then I can have access to your design. I can share it then with other folks, say, hey, this really cool thing was made in our class today. So that's another way to go about doing it. Okay?
Okay, but
It's not the best thing ever.
Oh, that's okay. It's more so just that we want everyone to be very excited about all the cool stuff you can make taking the library classes and participating in the library makerspace. So awesome. Well, thanks so much, you two. If there's no more questions, I'll go ahead and end the class, and I'll go ahead and send instructions about how to get on the makerspace, how to send your files to us. And yeah, if you have any questions, you can always reach back out to me and we'll go from there.
Goodbye.
Bye.
Awesome. All right, guys, have a great rest of your day. Thanks for participating.
You too.
All right, bye-bye.